Cloud computing. I'm Dr. Mary Cecil. Cloud computing is a shared resource that provides dynamic access to computing services. It can range from raw computing power, basic infrastructure, fully operational and supported applications. So what are the characteristics of cloud computing? On-demand self-service. A computing consumer can unilaterally provision computing capabilities such as server time, network storage, as needed automatically without requiring human interaction with each service provider. Broad network access. Capabilities are available over the Internet and accessed through standard mechanisms that promote use by heterogeneous thick or thin client platforms, such as mobile phones, laptops, PDAs. Resource pooling. The hosting provider's computing resources are pooled to serve multiple consumers using a multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. There is a sense of location independence in that the consumer generally has no control or knowledge over the exact location of the provided resources, but may be able to specify a location at a higher level of abstraction, such as country, state. Examples of resources include storage, processing, memory, bandwidth, or virtual machines. Rapid elasticity. Capabilities can be rapidly and elastically provisioned, in some cases automatically, to quickly scale out, and rapidly released to quickly scale in. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be purchased in any quantity at any time. Measured services. Cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction appropriate to the type of service, storage, processing bandwidth, active user accounts. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and the consumer of the utilized service. There are different cloud deployment models. The private cloud is dedicated and operated by a single enterprise. It's particularly prudent when privacy and security are key issues, such as in healthcare and financial services. Community cloud. Think co-op, nonprofit, or non-governmental organizations. The cloud infrastructure is shared by several organizations. Public cloud. Open to the public, the cloud can be maintained by a user group or even a fan club. In this case, the cloud infrastructure is made available to the general public or a large industry group and is owned by the organization. Hybrid cloud. This is a combined approach using parts of the aforementioned deployment models, private, community, and or public. It's a composition of two or more clouds. There are risks with cloud computing. When information is deleted or altered without a backup, it may be lost. Information can also be lost by unlinking it from its indexes, deleting its identifying metadata, or losing its eroding key, which may render it uncoverable. Another way data or document loss can occur is by storing it on unreliable media. As with any architecture, unauthorized parties must be prevented from hacking into the system and gaining access. Examples include basic operational failures, such as a service or disk drive crash, data center reliability, backup, and disaster recovery issues, implementation of information codes without approval of the customer. Many times damage to information is malicious, while other times damage is unintentional. Lack of training and awareness, for example, can cause an information user to accidentally compromise sensitive data. Organizations must have proactive information governance policies that attempt to combat either type of breach. The loss of data, documents, and records is always a threat and can occur whether cloud computing is used or not. But the threat of data compromise inherently increases when cloud computing, due to the number of interactions between risks and challenges, are either unique to the cloud or more dangerous because of the architectural or operational characteristics of the cloud. Ineffective encryption and software keys, including lost or inconsistent encryption, causes security challenges. Lack of document lifecycle security technologies such as data loss prevention and information rights management technologies can cause issues. Threats are amplified for consumers of cloud services by the convergence of IT service and customers under a single management domain, combined with a general lack of transparency into provider processes and procedures. It is important to understand the cloud provider's security procedures. How are employees screened? Are employee background checks performed? How is physical access to their building and data center granted and monitored? What are its remedial procedures for noncompliance? It's prudent to investigate the security and personnel screening processes of a potential cloud provider. When these security, privacy, and support issues are not fully investigated, it creates an opportunity for identity thieves, industrial spies, even national state-sponsored intrusion. The level of access granted could enable such an adversary to harvest confidential data or gain complete control over cloud services with little or no detection. For example, the cloud provider's employee could steal information to give to a competitor. Inadequate screening process could result in the hiring of people with criminal records. The cloud provider's subcontractor could steal information to give or sell to a competitor. The cloud employee could allow unauthorized access to data that your company believes is secure in the cloud. The physical cloud storage facility lacks security, so anyone could enter a building and access information. Although cloud computing providers, as a rule, invest heavily in security, they also can be the target of an attack, and those attacks can affect many client enterprises. Providers of cloud infrastructure services offer their customers the illusion of unlimited infrastructure expansion in the form of computing. Often this is coupled with an easy sign-up process, free trials, and simple activation with a credit card. This makes it very available to hackers who can assume multiple identities. Using these anonymous accounts to their advantage, hackers can engage in criminal operations while remaining elusive. Cloud service providers often have unknowingly hosted a malicious code, including Trojan horses, keystroke loggers, bot applications, and other programs that facilitate data theft. By its very nature, cloud computing solutions involve the movement of information. Information moves from a workstation to the cloud, from the cloud to a mobile device user, from an external partner to the cloud, and then to a workstation, and so on. Further information may be moved automatically from an application to the cloud to an application you host internally, and so on. This movement of information complicates the process of securing it, as now it must be protected at the point of origin, the point of receipt, on the device that transmits it. An application programming interface is a way of standardizing the connection between two software applications. APIs are essentially standard hooks that an application uses to connect to another software application, in this case, the system in the cloud. System actions like provisioning, management, orchestration, and monitoring can be provided using these APIs. APIs must be thoroughly tested to make sure they're secure and abide by policies. A chain is only as strong as its weakest links, so APIs must be thoroughly tested to ensure that all connections abide by the established policies. Some key things to be aware of: anonymous logins and reusable passwords can undermine the security of a cloud community. Unencrypted transmissions or storage can allow data theft. Rigid base access controls or false authorizations pose a threat. Poor management monitoring of cloud logins and activity makes it difficult to manage malicious behavior. Weak APIs is another opportunity for data compromise. Basic cloud infrastructure is designed to leverage scale through the sharing of components. Despite this, many component manufacturers have not designed their products to function in a multi-tenant system. Newer architecture continues to evolve to address this issue. In the meantime, virtual computing is also used, allowing for multiple instances of an OS to be walled off from others that are running on the same computer. Essentially, each instance of the OS runs independently, as if it was only one on the computer. A Hyper-V mediates access between the guest operating systems and the physical computer resources. There are flaws at times in these hypervisors. These can allow guest operations to allow inappropriate levels of control or influence in the underlying platforms. To combat this, security, enforcement, and monitoring of all shared computer resources must be employed. And of course, hacking into accounts to assume the identity of an authorized user has been happening almost since personal email existed. It can be as simple as stealing a password with a keystroke logger. Utilizing cloud computing resources provides an economic way to scale IT resources, which allows more focus on the core business functions. It can render significant business benefits, but also its risks must be weighed carefully, and specific risks must be countered in the context of long-range cloud deployment plans. And information governance can help. A set of guidelines aimed at helping leverage cloud computing in a way that meets business objectives without compromising information governance profiles is presented. As with any technology implementation, it's critical that you define your business objectives first. Then select the provider that best fits the business objectives, provided, of course, that it can meet the requirements. This is consistent with applying a proven IT project management methodology to the initiative. Even though the solution may reside outside your environment, the same basic phases to the project approach still apply, especially for those tasks related to documentation. As part of the project documentation, make sure to identify roles and responsibilities related to the system in at least the same detail that you do for internally supported projects. The biggest deviation from your standard approach is the need to incorporate the investigation and application of the appropriate fixes described in the security threats section of your project plan. Again, with any service contract, it's helpful to involve a good contract negotiator. The contract negotiation phase is when you have the most influence with your provider. Therefore, you have the greatest chance of mitigating potential risks and optimizing the benefits if you can get and incorporate special requirements into the contract language. If the cloud computing paradigm is relatively new to your organization, try to figure out approaches to issues and high-level processes that can be used in subsequent cloud computing projects. Microsoft Azure is one approach that can help with cloud governance.
All right, so hello, thank you for coming. My name is Dana Baxter. How many people watched my talk on SCOM migration earlier? The jokes are all the same, so I'm sorry. Like, you're just gonna hear like mostly repeat content. So, but I still do have more crappy prizes. So if you didn't get a crappy prize, I see someone excited in the back. There's still opportunity, unfair questions, crappy prizes. It's gonna be great. All right. So my name is Dana Baxter. I work for CSENO, which is the new name for MSIT at Microsoft. So CSENO stands for Core Services, Engineering, and Operations. We have the same function, essentially, but they rebranded us, I guess, because, you know, CSENO is like is new. So there you go. So here is the problem. I think you guys probably all had this problem, right? All right. So I'm old. I've been in ops for a long time. And in the olden days, you know, everything was very controlled. We had an ops team. You had people who deployed servers, people who managed change requests, people who managed incidents. And if you wanted to deploy applications and services, well, you submitted a request and you got some kind of budget approval and somebody built out your server for you, all golden stamped and awesome. And it totally complied with all the security policies, and they give it back to you and they're like, here, go, be free, run your application, right? And then Azure happened, and it's chaos, you know. So everybody is just pulling out their American Express card and buying subscriptions and deploying, VMs all over the place, and everybody's freaking out. And especially the ops team were like, what do we do about this? Like, we're supposed to be managing security, we're supposed to be managing deployments. Like, these people are just going nuts. So it really fractured our environment. So we had this one set of people who were in this very controlled environment. They're on-prem stuff. They're getting GPO. They're getting all this stuff. We have admin access to the servers. And then we have all this other stuff going on in Azure where people are spinning up VMs and deploying resources. And, you know, and from the leadership down, they're saying, go deploy, learn, innovate, do cool things. So it's not even like we could really stop them. But at some point, we kind of had to draw a line and figure out, as an operations team, how do you then deploy any corporate policy or standards across your environment. And so I don't know, does anybody else have, I've talked to some other people today who said that they kind of have the same situation where they have people who are spinning up Azure subscriptions and building out VMs, and they're just doing whatever they want. Does anybody have that going on today? Yeah, okay, so I'm not alone. Yeah, 2 hands, right, all right. Yeah, it's, oh, everybody gets a beer, you know, after this, over there. So yeah, so that's the problem. So what we had to think about was the fact that we needed to be able to at least apply security controls across the environment, but we had to do it on things we didn't have access to. Everything was very manual. And so we came up with a toolkit. Has anybody used the AZSK? Yes. Oh, you should get a prize because that's prize-worthy. Fix the battery in there to make it work. All right. So the AZSK, if you don't know what that is, it is a toolkit. We call it Glue because it's something that we put into place in the meantime until Azure natively has these features available. And basically what it is you download this commandlet, you run this PowerShell script, and it will scan your subscription and your resources for about 280 different security controls. So right now, it also deploys 7 Azure policies. So we in CSE&O, we have 753 subscriptions. We have about 18,000 VMs, and that's hybrid, and that's both on-prem and in Azure. And we have about in upwards of 300,000 resources. So we have this now as a mandate that everybody deploys the AZSK. It used to be called AZSDK, and so I get very confused, but they've dropped the D now. So AZSK, and for us, instead of using all 280 of the security controls that the tool is able to scan for, we just have a baseline of 32. Now, I had to look at my slides just to make sure. We have 32 that are absolutely required inside our organization. So even if you get this scan, it's not every single thing. And so we're scanning about 81,000 resources. The problem with this, though, as cool as it is, and as much as it scans, and as much as it checks for, and there's all this glorious, massive amounts of detail that's given to you in spreadsheets and outputting to log analytics and these dashboards that you can build on top of it, is that it's all manual. You know, when I first found, I was one of the first groups to pilot this tool. I personally have probably installed it 600 to 1,000 times. I don't even know, like I was blind with AZSK. So it's very manual, and so that can give us a lot of problems. And so what we're really excited about is the fact that policy is becoming more popular, and that management groups are going to be a way that we can deploy this. Sorry, I probably should have skipped ahead to this one slide a little sooner. Go ahead and read the slide. I know that that's the thing. You're not supposed to put so many words on the slide, but these are all links to the individual sections inside the AZSK. I would say that the things that I would want to focus on here is there's a group of controls that just checks for subscription security. And that's all subscription level checks that it's doing. The secure development, this is going to give you 2 things. This is where it's going to check all your resources, and then it also gives you some tools so you can even use it while you're doing development. And then the other thing I would like to focus on is the continuous assurance. So AZSK is something that you could just run one time. You could just download it, run it, kind of see what your baseline is. But if you like the results, if you think that they're valuable to you, which I actually think that you will, then you can set it up to run on a daily basis and output that into your workspace. And so for us, I think that initially our compliance was pretty low, like around 50%. Like because people were just doing anything that they wanted to. Like I said, they were just American Express subscription, deploy whatever you want. There you go. Call it a day. Nobody was complying with security policy. So this was a really good way at a leadership level for us to be able to assess our security risk and be able to hold people accountable. So the other kind of aspect of all of this change is that IT operations is not really a centralized service anymore. We're really, is DevOps like the newest buzzword ever? Yeah, okay, so we're totally doing DevOps, which basically means that I don't do the work, I enable you to do the work, right? So the AZSK was really helping with that. So we went out and said, okay, install this on all the subscriptions, and now you're responsible for making sure that your subscription or your service is 95% compliant. And even today, with 753 subscriptions, we're about 96%. So it's actually, you know, pretty good. But like I said, everything about AZSK is very manual. The deployment is manual, the enforcement is manual, the reporting is all centralized. It's not creating tickets or doing any auto remediation, and then the remediation is manual. So even though the AZSK does come with some PowerShell code, so that, you know, say it checks for TDE on an Azure SQL DB and you want to turn it on, you just can run the script with the switch and it will enable it for you. Now, that doesn't mean you should, it also will let you bulk fix everything, which I don't recommend. You should totally like try it first and then make sure nothing explodes and then you'll turn it on. But it actually is pretty cool. These are the policies that the AZSK is applying today. And again, these are all opt-in, opt-out. You don't have to do these, but these are the only policies that we're using right now. All our other controls are coming from AZSK. So here's what we're looking forward to. So out of all those 280 controls that AZSK has built inside of it, we've been working with the product group to make it more built in, because our goal always in CSE&O is to be as close to native Azure as possible, and AZSK is not native Azure. You know, it's just something that we made. It works very well. It's available to you all, by the way. You can get it on, I think it's github.com/AZSK. I got some links at the end of my slide with more information. But the thing about, so 74 of them are now ready for pilots. And 19 of them came directly from infrastructure. So we have 74 that are coming from AZSK that are security related, and then we have 19 that came from infrastructure. So my particular area of focus is I'm the manageability service manager, so I care about like the monitoring agent being installed on all the VMs. And so we have that coming in as policy. We also have one coming in because we care very much about Azure resource groups being tagged. And so things like infrastructure requirements, especially at a broad level, these 19 are going to be available for built-in, but with policy, you know, you can also have custom. So the 74 that we're rolling out will be custom policies. The other thing is management groups. So does anybody tried management groups? All right, management groups. Maybe I should give away some hand sanitizer. There you go. There's the present. So management groups, we're out. So I'll just be honest. I mean, because they wanted CSE&O to present today, they also realized that they have to suffer the fact that we're just another operations team. We're not part of the product group, and we're not always as far along as we'd like to be. So right now we're just piloting management groups. We haven't actually deployed it on any of anything production yet. So these two items under my production management group's adoption are the two things that we're waiting for the product group to release before we move it into production. So the first thing is activity logging. So I don't know, with your experimenting with management groups, if you make a change, it doesn't log it anywhere. You're like, that's not okay. That's not okay. You can't do that. It's not all right. So there's that. And then we need improved RBAC for management groups. So for instance, you know, Aileen up here, she has a subscription, and I want to put her subscription into a scope. She has to give me access to her subscription. And if I'm an admin in both, now I can make anybody here an admin, and that's also not okay. So we're looking for some improvements in those two areas, but in the meantime, we're just going to be piloting it. But the cool thing is that all this stuff is going to be so much better. So the deployment is automated. You just have somebody who manages, like we have a governance team, you know, so people who are engineering policy and management groups, they'll be able to put this out for us. And then the other thing that's really cool I don't have the demo for this, but they're going to be releasing this week. So they're going to be doing automated remediation or remediation through the portal at the policy level. So when you go in to look at the reports and you see, and personally I haven't seen it, I'm super excited, but I could tell you what I think it's going to look like, and apparently there's a button, and you click it, and it fixes it, and I'm like, yes, and then you can write scripts around it, so that'll be really helpful. So these are the other two sessions that are coming up. This guy, Joseph Chan, he does this. It's dance party time. Joseph Chan, if you can get to his session, I really, really recommend it, because he's going to go into a lot of detail about how... he has this great line. He's talking about how in the early 2000s, when VMs became a thing and everybody could just go in and spin up a VM on a host, and then VMs just got totally out of control. Well, this is kind of like this all over again. It's just a total repeat. So now instead of VMs on hosts everywhere, you got VMs and subscriptions everywhere. And he calls it cloud sprawl. And I really like that word. Anyway, the way he describes it is just perfect. So I really recommend that you go and see at least the first one. Does anybody have any questions? I think I went through that kind of fast.
So we looked at cloud computing, characteristics of cloud computing, cloud deployment models, risk associated with cloud computing, information governance, guidelines, and then looked at Azure policy deployment.